So last class we had discussed what the basics of, what are acids, what are bases. So what defines an acid? Who had attended? Divya. Divya. So what defines an acid? Like anybody else wants to say, you can. Puneet has given the taste of it, but chemically, like in terms, if you look at the molecule, what gives acids, like that property of acids? Abir, no, you confuse acids and bases. Like watch the recording again, Abir. Jaden had mentioning in terms of litmus, yes, turns blue, litmus red. That is absolutely right. But chemically speaking, what gives acids the property? Very nice. Okay, so some of you have sent in, yes. So some of you are talking about it in terms of pH. That is more of, okay, how do you identify acids? But what gives acids the property is that acids liberate H plus in solution. So
H plus ions.
H plus ions, hydrogen ions. Yeah. So Neki got it. Elena got it. Abir, yes. You got confused between H plus and OH minus. So that part you need to correct a little bit. Puneet got it. Dhruv got it. Rishita didn't mention H plus, but yeah. Okay. Awesome. Aditya, yes, we sent in H plus ions. And similarly, chemically speaking, what defines bases? Like how do you figure out, like where do bases get their properties from? Awesome. Dhruv is sent in. Yes. Abhishek, Neki, absolutely right. So bases release OH minus ions, also called hydroxyl ions in solution. Okay, so the main thing to remember is that this ionization, releasing H plus or OH minus, happens only in the presence of water, either water or like polar solvents, something that's already ionic in nature. But mostly, yes, for practical purposes, you use water to get the properties of acids or bases. Okay, so based on this, we discussed a few reactions, the reactions with metals, with metal carbonates, bicarbonates. So continuing with the reactions, today we'll be talking about neutralization reaction. So this is reaction property number 3. Neutralization reaction, who can say what is neutralization? Whatever idea you have already.
Ma'am, when an acid nullifies a base or when a base nullifies an acid?
Very nice. Okay.
When a strong acid reacts with weak base, like that time.
That, okay, not completely. Like it doesn't have to be strong, weak, like it's not defined by strong or weak. Simply speaking, when acid reacts with a base, and one of you said nullify. So nullify in the sense they neutralize each other, and how they neutralize, like what do we see it as, is they produce salt.
Ma'am, acid plus base is equal to salt plus water.
Puneet, all your products are not right. So let's see. So neutralization reaction.
H2O.
Yeah. Acid plus base gives salt ionic compound plus, so water is the one that's being produced. So now let's look at the mechanism of it. So acids, we said, are defined by the presence of H plus ions. So acid can be written as any random HA, H plus, and this is the anion. Base, let's write it as BOH. B is any random cation, like it could be Na, it could be K, it could be NH4, and OH minus ion is being produced. Okay, so when acids ionize, what ions do you get out of it? Yeah, Mansi.
Anion.
So if the acid is HA, like so for example, if it is HCl,
H plus.
H plus and
Cl minus.
in case of If it is Cl, then it would be Cl minus, because we considered our acid as HA. A minus is our anion. Similarly, what ions do we get out of the base, Jaden?
Ma'am, B plus and OH minus.
Very nice. Yes, B plus, B is the cation, and OH minus. So if these 4 ions are there in the solution, what salt will you get out of this? Who's gonna answer this one? Tanisha? So what ions will combine to give you an ionic salt? Not sure. So check what ions are attracted to each other. Similar, like same charge or opposite charge?
Opposite
Charge. So uske basis pe, what ions will be attracted, like H, A, B, OH?
Ma'am, can I?
And B will get attracted.
So A has minus charge, B has positive charge, so these two will get attracted. So your salt will
Ba plus HOH.
yes, and remaining H plus and OH minus will attract what?
H2O.
Yes, HOH. This is basically a water molecule, H2O. Okay, so that is basically the mechanism of a neutralization reaction. That's how your salts are formed from acids and bases. Okay. As always, yeah, note down neutralization, note down this part and this part, like this, showing the mechanism. If you want, you can like draw boxes or arrows to, like make the understanding, like you take down notes for yourself. So however you feel like it's easy to understand, be it arrows or boxes, make those markings. And once you're done, yes, we'll practice some equations. So examples. Yeah, let me know when you're done noting this down. Then I will, yeah, we'll write some equations. Okay, Nancy is done. Deshna is done. Okay, Shakti, Jaden, Puneet, Jasmine. Cool. Abhishek, Vasudha, Bhavika. Bhavika, Abir, like people who were absent yesterday, right? Let me know if there's any point you're not able to follow, if there's anything that's not making sense. Ask immediately. You don't want that to, be pending. You'll face problems later on. Okay. Okay, good. Majority of you are done. Sarah, who is this? Ame, Ryan, Divya is yet to finish. Aditya is yet to do. Okay, Ryan is also done. So Aditya, Raghav, Neki, this is Dhruv, right? Raghav is also done. Okay. Awesome. So those who are done, get started on this equation. We'll start simple. HCl plus NaOH gives again, send your answer either on chat or you can write it in your book and send me the picture on WhatsApp, whichever is easy for you. Send your answer. Yes, Dhruv got it. First one, like I expect 100% of you guys to get it because this is like a really simple, obvious equation. It's used in a lot of places. Vasudha Deshna, absolutely right. Sulfuric acid के साथ what base take? Check your answers. So Dhruv correct, Vasudha correct, Deshna correct, Abhishek Trivedi first one right, Elena first one yes, Manisha first one right, Dhruv second one yes, Bhavika first one right, Deshna second one yes, Jasmine first one right, Vasudha got the second one right, Mansi is correct, Puneet yes you got both of them, Aditya yes first one is right. The third one, okay, since okay, was already written it. Okay, I will change it. Okay, so Tanisha got the second one. Vasudha is second. Third is right. Dhruv got the third one right. Deshna, the third is right. Abhishek, yes, you got it. Tanisha, no. So the third one, I think you typoed. Yeah, I figured it was incomplete. Okay. Mansi, yes, second is right. Vasudha got the fourth also right. Elena, yes, second is right. Very nice. So Elena has been sending balanced equations. That's good. Deshna, yes, got the fourth one. Jasmine, yes. Second is right. Puneet, yeah. Third and fourth, you got it. I think you have your caps lock on. Just ensure that you write it properly when it comes to things like CL. L should be small. Tanisha, yes. Third is right. Okay, Raghav has sent on WhatsApp. I'll check it in a bit, Raghav. Ritvik, first one, check the formula. What is valency of Na? Otherwise, rest of it, 2, 3, 4 are correct. Abhishek, again, valency, like the formula is wrong, but your idea is correct. Third one, Abhi jo bheja hai, uska answer. The formula galat hai. Valencies dekh ke you need to put it properly. Rishita sent all 4. The products are right, Rishita, but your equations are not balanced. So take care of that. So when you're writing in your notes, once you got your products, ensure that you balance the equations. Divya, yes, fourth is absolutely right, but I hope you write exactly the way you send it in the chat in your notes also. Otherwise, there's no point to you writing the notes, Divya. Write it properly when you take it down in your notes. Jaden, 1, 2, 3, your products are all right. Just your notation, just ensure that you write it properly when you take it down in your notes. Tanisha, yes, you got the fourth. Ritvik, yeah, now you corrected it, first one, yes. Aditya, first 3. The second one, like assume complete ionization. It's not partial. So the hydroxide, like the H plus OH minus, assume complete ionization and give the product. The third one, the salt is correct, but yeah, mention water also. Jasmine, you got the third. Mansi got fourth.
Yeah, ma'am, by mistake, I pressed enter.
Okay. Jaden got fourth. Elena got third. Yes. Jasmine got fourth. Nice. All of you are answering correctly, barring 1, 2 cases where valencies that you need to keep revising, like that will go on throughout the year. But conceptually, like neutralization ka point, all of you got it. You get salt plus water. Very nice. You can predict the products. Only thing is you guys need to practice valency. And second thing, because it is over chat, over Zoom, I'm not nitpicking too much, but when you write it in your notes, absolutely take care of your, equation should be balanced. Your capital letter, small letter representation should be okay. Like now, because you're typing, okay, like I can let it slide, but please keep that in mind and take care of that. Otherwise, you will lose marks unnecessarily. You don't want that. Okay. So the first one, salt is NaCl plus H2O. Second one, calcium sulfate. Most of you have got it. And H2O. But if you look at it, you have 2 OH plus and 2 OH minus. So balance करने के लिए 2 H2O जाएगा. This would be K2SO4, potassium sulfate, and H2O. Balance this equation properly again. H2, H2, OH, K2. So this will be.
Ma'am, it would be 2H2O, right?
Yeah.
Next.
Ma'am?
Yeah.
Ma'am, is calcium sulfate aqueous?
Calcium
The
sulfate.
state? What is the state of calcium sulfate?
Oh, so all of them would be aqueous only.
Okay.
And this will give you ammonium chloride, NH4Cl plus H2O. Valency सबका एक ही है, like this is also balanced. Yeah. Salt is always aqueous. Water, it's pure water in liquid state, so water will be in liquid state. And acid base also, like by default, all of them will be in aqueous state, because you will always like dilute them in water and then do it. Sarah, yes, I got all 4 of yours in one shot. All of them are right. Aditya is also right. Raghav, I was supposed to check yours on WhatsApp, no? Just give me a minute. Oh, I think you corrected it. Okay. Salt, it's all correct. And equations are also balanced, yes. So just take care of your representation. I don't know if L is capital or small. Just, yeah, it's in your writing. Just be careful. That's it. Okay, awesome. Just one more equation, because I want you guys to be familiar with it.
Ma'am,
Yeah.
for bases also, the state we have to write aqueous, right?
Yes. Acids, bases, all of them are aqueous. They will not react if they are not in aqueous state. Okay. Okay. All right. One last reaction for neutralization. CH3COOH plus let's go MgOH twice. So what would be the products of this neutralization? I want you guys to be familiar with writing acetates. Vasudha, yes, like technically you're right, but representation, again, I think we touched on this yesterday also. So Mg will replace H, so it will be on the other side. Okay. Again, organic chemistry weirdness. Puneet, my feedback to you is the same. 2 points actually with your answer. One is check the valency. Like यहाँ पे CH3COO is attached only to single H. So acetate का valency क्या होगा? Based on that, you need to modify it. And second, again, magnesium will simply replace the hydrogen when, in the salt formation. So it will be your cation anion will be reversed in this case. Yes, Vasudha, Deshna, yes, you got it. Rishita, yes, but equation is not balanced. Just check that. Elena, yes. Okay. Most of you are getting it right, like valency and, salt formation, you're getting it. Representation may, it will be slightly different. So I'll tell you what the correction is. Ritvik got it, Raghav got it. Raghav, one small modification. When you have multiple atoms, right, put it in brackets. Otherwise, it will mean different thing. Dev, we got it. Jasmine got it. Puneet, you missed out one C, but I think I'll take it as a typo. Aditya got it. Tanisha got it. Sarah got it. Bhavika got it. Nice. A lot of you are getting it. It's good. Abhishek, not quite. Also, when you send it properly, no? Okay, so you guys have the right idea that CH3COO part will form the anion and it will combine with Mg cation. Mansi, your representation is right, but valency mein galat hogi. Abhishek, no, actually, no. Okay, now CH3COO का valency क्या होगा? Mansi, yeah, now you got it, but you need to enclose it in brackets, okay? But yes, CH3CO acetate ion. So this is called the acetate ion, क्योंकि acetic acid से आ रहा है. Acetate. Yes, Nikki, correct. So this would be -1. Okay, Vasudha also got it. Sent 1. Abhi Mg, what cation will this form? इसका valency क्या होगा? Abhishek? Abhishek Trivedi.
Yes, ma'am.
Yeah, what will be the valency of magnesium?
2 plus.
Correct. 2 plus or +2. So remember crisscross method. तो किसके नीचे 2 आएगा? Mg के साथ आएगा या फिर acetate के साथ आएगा?
Acetate.
Acetate के साथ आएगा. That's correct. Okay. So Mg will be single and this will be multiplied by 2. So the salt will be, if it was a normal anion, Mg, you would have written it as a lot of you have guessed it. But with acetic acid, because it's an organic acid, it gets special set of rules. So the salt in this case will be CH3COO. This taken twice, Mg. So this is magnesium acetate.
Ma'am, we don't write Mg first.
No. So normal, like, what do you call it? Mineral salts, yes, magnesium will come first. Like if it is sulfate, nitrate, chloride, any other anion, magnesium is supposed to come first. But because this is an organic acid, the rules kind of change a little bit. So CH3COH may H gets replaced by Mg, which is why Mg is written at last. So another interpretation, or another reason why Mg is written is that the anionic part is concentrated on oxygen. So it is not over carbon, it's not over this carbon, like it's not over any of these. The Mg2+ that is there, it is going to form that ionic bond with this oxygen at the end. That is the reason why Mg is written towards oxygen. Okay, so we'll learn more about why organic compound rules are different and why they're special in carbon in its compounds. But yes, so only for like acetate ion, acetic acid, the rules kind of change a bit. Plus water, B2H2O and 2 times acetic acid to balance it out. Okay. So this I wanted you guys to get familiar, get used to it. So whenever you come across acetate ion, This is how you write the formula. Okay? This is like one special case. So, and this is a special case only because this is an organic acid. Which brings me to the next part of the chapter. So neutralization. Oh, another important point about neutralization reaction is that it is extremely exothermic. So if you use really tiny, like extremely dilute quantities, then it is safe. But if in case you take a really strong acid, like our first example, HCl plus NaOH, if this is also strong and this is also strong, like really concentrated versions of both of these, if you don't do it carefully, you will end up with an explosion. It's going to be violent. Okay, so neutralization reactions are extremely exothermic reactions. So you need to be really, really careful when you're doing these reactions. That is the reason why it is, all of them are aqueous in nature, because water basically dilutes the acid. So dilutes ka matlab, it lessens the strength of it. It makes it weaker, basically. Which brings us to the next part of the chapter. So this whole part will come under something called physical chemistry. Physical chemistry, like we'll be dealing with physical measurements of it, how strong an acid is, how strong a base is, in terms of numbers, like what is the concentration, all of those bits. Okay.
pH scale amount.
Yes, pH scale is how you measure the strength. Okay, so what happens to acids and bases when you put it in water solution? Yeah, what happens to acids and bases when you put it in water?
Acids give out H plus ions and bases give out OH minus ions.
Acids ionize.
Very nice. Two of you together have given the complete answer. So if you put acids and bases in water, okay, let's take it one case at a time. In water, if you take an acid, what takes place is ionization. Yeah. The ionization takes place in water because of something called polar nature of water. Have any of you heard of the word polar before? Like, what do you mean by polarity of water or polar nature of water? Water is a polar solid. Yes, no? Okay, Vasudha says no. Okay.
No, ma'am.
No, okay. So, where do we start? Okay. Do you guys know what is the structure of water molecule? Like, have you come across it anywhere randomly?
HOH.
HOH, yes, that is like the most simple way of saying it. Yeah, water is made up of 2 hydrogen atoms and 1 oxygen atom, right? So if you look at water under an electron microscope or something, like if you had to figure out what is the structure of water, so oxygen is in the middle. This is, let's say, oxygen atom, and it is surrounded by hydrogen atoms. So this is like the shape of water molecule. So बीच में oxygen है and the blue ones are hydrogen atoms. ठीक है? The reason why it is in this shape will become clear to you. Like we'll have to get into, like electron, like molecular geometry and all of that. We go deeper in it in 11th grade, but for now, yeah, just know that this is the structure of water molecule and it is exactly in this shape. It's bent. The reason why it is bent is because there are two pairs of electrons on oxygen. Do you guys remember the electronic configuration of oxygen?
It's 8, 2, and 6.
Very nice. So oxygen atomic number is 8. How the electrons
2,6.
is 2,6.
2, 6.
Yeah. So 6 electrons जो है, उसमें से 2 electrons are bonding with hydrogen. So the remaining 4 electrons क्या कर रहे हैं? They're just there over here. They're just chilling here. Okay, that's the reason it is bent. Now, what sort of charge does oxygen? What sort of charge do electrons have?
Negative.
Very nice. So negative charge. No? So if you consider water molecule, can you see that because the electrons are here, this end is negatively charged and this end will have more of a positive charge. More electrons concentrated here, that's why negative, and less electrons concentrated on the other side, so it has a positive charge. Is this making sense?
Yes.
See, you don't have to memorize all this. Just, you don't have to write down all of this. This is purely for your understanding. So just focus here and let me know if it is making sense or not. If it's not, I'll I'll tell you guys in a shorter way. That's
Yeah, ma'am, just explain once again.
okay. So simple. You don't even have to know the shape of water molecule and all that. All of that will make sense later. But main point is, because of the shape of water molecule, one side of it is negative and the other side of it is positive. One side of it is negative because of the presence of the electrons, more number of electrons on oxygen molecule. वहां तक समझ में आ रहा है? Like is that like okay with you? Like, can you accept that?
Yes, ma'am.
Yes, ma'am.
Yeah. So because of the shape of water molecule, one side is negative, like you have more of a negative charge, and the other side you have more positive charge, like less negative charge. Okay. Now, because there is separation of charges, because you have one side slightly negative charge and the other side slightly positive charge, so basically this creates something called, like, it's like having two poles of a magnet. Do you guys remember magnet में दो poles होते हैं? Which are the two
Yeah,
poles?
north, south.
North south poles, right? And what does the behavior of those two poles remind you of?
Like ones repel, unlike ones attract.
And that's exactly like your charges, right? Like charges repel and unlike charges attract. So that is the reason why water is called a polar molecule. Yeah. Now, because of this polarity, yeah, this is the reason why acids and bases are able to ionize it. Now, because water has a tiny bit of charge separation there, whenever it hits the acid molecule, base molecule, it is able to separate out the ions. Now, this particular part gets important in the next bit of it. Take an acid. Let's take HCl. If you mix it in water. Okay. Till now we've been studying. Acid ionizes as H plus and Cl minus, right? Now H plus is basically a single proton. So hydrogen has like one proton and one electron. Agar isko positive charge diya, तो electron gets out of the picture. So basically H plus is nothing but a single tiny little proton. So one single proton just like floating around in water, it is not capable of existing independently. So what it does is the negatively charged electrons that are there on oxygen, that positively charged proton gets attracted to it and forms something called a hydronium ion. So it forms H3O plus. So this is called a hydronium ion. And of course, apart from that, you have your regular Cl metals. Okay. So just summarizing it once again, if you consider water, now why are we talking about water? We're basically discussing what happens when acids and bases are put in water. Okay, so first acids. When you put it in water, now water molecules are polar in nature. Polar matlab one side of the molecule has more negative charge, the other side has more positive charge. So there's like two different charge, there's a charge separation that's created. When acids are put in water, step one, ionization takes place. Acid gives out H plus and the other anion is there. Now H plus is a singular positively charged proton. It's like tiny, it's always like zipping past. It is not capable of existing on its own. Like imagine a baby. Can a baby survive on its own? It can't. Like it needs to take help of its parents or any other adult. So the tiny single proton gets attracted to the negative side of water, which is basically towards oxygen. And that's how it creates this ion called hydronium ion. So that's H3O plus. It's literally water, which is HOH. And the extra hydrogen from acid is basically bonded to the oxygen here. And because it is one electron short, because the hydrogen doesn't have an electron, there's a positive charge to it. So that's hydronium ion, plus the anion is always there over here. Okay. So this is what is happening in reality. So when you put acids in water, acids ionize, and eventually, like finally, what you find in the solution is H3O plus, hydronium ion, and chloride or whatever anion, chloride, sulfate, whatever you. Okay? All of this you can ignore. It's just. Okay. Guys, got it?
Ma'am, should we note it all this?
Note down this part. This is important for your syllabus. In case you find it useful for your understanding, you can note down the extra stuff. But this is what you should mainly remember. So when you add acid to water, hydronium ion is formed along with the anion. So for convenience sake, because proton is the one taking part in reactions and all, on paper we write it as proton. But in reality, like if you do the analysis, if you observe it under electron microscope, this is what you're going to find, hydronium. This is reality. Okay.
1 minute, ma'am.
Yeah. Note it down. If any of you wants me to repeat at least like the important points of this, let me know. I will repeat it. If you've gotten it, let me know. Then we can move forward. Otherwise, I'll go over it again. Yes, Shaden, what's up? Oh, is that you saying that you're done noting down, or do you have?
Yes, ma'am. Yes, ma'am.
Okay. Okay. Vasudha and Jaden are done. Okay, Bhavika, Nancy, Jasmine, Sarah. Okay, Rishita, Elena, Aditya, Tanisha. Ryan, Puneet, Deshna, Nikki is done. Okay. So Abhishek, Amey, Dhruv, Raghav, Ritvik, Snehal, and Divya. Snehal is also done. Ritvik is also done. You guys, like, I don't like you being quiet. Like, I can't see your faces. Video to thoda lag hone lag jata hai. But you guys can talk and interrupt. Let me know whenever any part is getting confusing or anything like that. Okay, Devi, are you there? Okay, all of you are done except Divya, but his audio is also not connected. Divya Kandhar, are you there? Are you up to page? Like, you updated? I'll have to like ping on WhatsApp then. Okay. Yes, Tanisha. So done? Or do you have a doubt or something? Done. Take it.
Okay.
Yeah, Elena.
Ma'am, I just had a small question. So does an acid split into hydrogen and the other ion because water is a polar molecule? Like because one side of the water molecule is negative and the other is positive.
Yes. So the polarity of water like basically contributes to, yeah, in the absence of water, they don't exist as ions independently, but in solution, they do. So the polarity of water definitely plays a role in this happening. Because you have HCl, originally it's a normal covalent compound. Something needs to break the bond, right? So the like polarity of water is able to get the hydrogen away and make it attached to itself and ionize the acid basically. So yeah, you can say that polarity, because of the polarity of water, acids are able to ionize. Yes. Okay.
Thank you.
Okay. So this is the story of acids. Okay. So acids ionize. In reality, H plus ions are not capable of existing. They don't stay like this as H plus. They immediately attach themselves to the nearest water molecule and form hydronium ion. Okay. Now coming to the story of bases. Bases also undergo ionization in water, and because of the polar nature of water. So if I take an example, NaOH in the presence of water, so basically NaOH simply breaks down into Na plus and OH minus. OH minus is like significant enough, it's got bulk, it can exist independently. So there is no issue. It's not like H plus, turning into a different ion or anything. So bases is pretty straightforward. You get a cation and OH minus ion conflict. And water is there. Water may exist as H plus OH minus themselves. So that's it. So basically, bases undergo ionization. They break down into Na plus and OH minus.
Mom, what do products I can't see properly?
Shakti, I am unable to, like, you're not completely audible. Can you repeat that?
Could you write the products of the NaOH plus H2O equation again?
Okay, I'll do it in the next page in case it's not visible. So bases NaOH, when you put it in water in the presence of H2O, it just splits into Na plus and OH minus. And by the way, ions ke liye, the states are all aqueous only. Here, ions are not capable of existing outside of water. Hi Devi, what's up?
Ma'am, you called me, no?
Yeah, there's been no response from you. I'm not sure if you have written down the notes, if you got it, if you had any doubts, anything at all.
No, ma'am, nothing like that.
Okay. Your audio was also disconnected when I checked there, so I was wondering if.
No, ma'am, it may be a glitch. Yeah. I was listening. We are doing acids.
Okay. Cool. Perfect. So this.
Balance question.
Yes, Neki?
Can you balance the situation?
Balance, I mean, single NaOH gives a single Na plus ion and a single OH minus ion.
But then on the left side there are 3 S, on the right there is only 1 S.
On left side there is, oh, so this water, okay, so this water, like that's the reason I took it out of the reactants and put it as a condition over here. If I put it as a reactant, then
Can't we write it as reactant?
if you write it as a reactant, then write another H2O over here, basically, because
Okay,
H2O is like always present. That's the medium. So
Yeah,
in H2O, this whole thing is happening.
So, ma'am, it won't happen like the acids one.
No, bases are not that complicated. They just give out OH minus ions and that's it, they're happy.
Okay, ma'am.
Yeah, so this is what happens when acids and bases are put in water. And this is like the start of the story. This is what contributes to all the reactions. So when you do a reaction, this is how it proceeds. So first, the acid or the base ionizes. These are the products that are formed. And yeah. Okay. So which leads us to the whole concept of strength of acids and bases. Yeah. So when we talk about the strength of acids and bases, okay, I'm assuming that single equation, all of you have noted it down. It's been a while.
No, I'm noting.
Okay.
1 second.
So acids ka, after noting down about the hydronium ion, yeah, just note down like bases. Again, same thing in water. This is the reaction that happens.
Done, ma'am.
Okay. Strength of acids and bases. Okay. What is the difference between HCl and, let's say, citric acid? Both are acids, matlab both give out H plus ions, but
HCl is more reactive because citric acid is organic.
I mean,
HCl gives out more H plus ions as compared to citric acid, so it is actually more reactive.
That's nice. Good way to put it. But simply speaking, which would you rather touch or drink? HCl or citric acid?
Citric acid.
Citric acid, that's right. And the reason, yes, Neki and Puneet have mentioned it. So citric acid, citric acid is considerably weaker than HCl. HCl is a really strong acid. The reason is lots of reasons. Yes, citric acid is organic. That is one reason why it is considered to be weaker. As Puneet said, another factor in the difference in strength is that HCl gives out a lot more of H plus ions as compared to citric acid. Okay, so those are like the two contributing factors to the strength of acid. Divya is saying citric acid is dilute and we also consume it daily. Well, it is dilute, that's why we are consuming it daily. But you used a word called dilute. So if I say something is dilute, is that like a property of the acid, or is that something that you can produce? Like, is that something being dilute, is it in your hands, or is that like nature? What do you understand?
Both.
Both, interesting. Okay.
In our hands.
Puneet is saying in our hands. So we have a vote for both. We have a vote for in our hands. Neki is also saying, okay, it's not a property. It means mixed with water. Anybody else have thoughts about it? Reshna? Rishita? Jasmine? Any of you guys? Raghav? Rishita also said the same thing as Neki, like you add water to make things dilute, so it's not really nature. So Divya, so something being dilute is not a property of the acid. It is something that it's an action, diluting. Puneet said acids are either weak or strong. We add water to make them useful for us. Absolutely. So in a way, the strength of acids is also something that we can control. Okay. So diluting basically means mixing with water. Absolutely, as Neki and Rishita have said, dissolving something in water in order to make them, in order to reduce their concentration. So in order to make them weaker. Okay. So yes, citric acid is weaker than HCl because the property of citric acid is that it cannot give the H plus ions as easily as HCl. So that's what makes it a weaker acid. So something being dilute is something, it's in our hands. Okay. So here's how you can like visualize it. So water, something being acidic or basic is all in the measurement of your H3O plus ions and OH minus ions.
Ma'am?
Yeah, Aditya?
Ma'am, your video and your voice is lacking a lot.
Oh. I am sharing a
I'm not sure, maybe.
You guys are able to see it?
Yes,
Yeah, ma'am,
ma'am.
your voice is clear.
Yeah, not lagging for me.
Okay, then Aditya.
So it would be for me only.
Okay. So if you have not added any sort of acid or a base, when you have natural water, right? Just simple water, maybe you have H plus ions and OH, H plus obviously existing as H3O plus and OH minus ions. So what is water? Like, would you classify it as acidic, basic, or neutral?
Neutral.
Neutral.
Neutral, right?
Neutral.
Yeah. So when we are adding an acid or a base, you're not, you're not adding new kind of ions to it. You're just manipulating the quantity of H plus and OH that is already there. So the whole concept becomes, if the quantity of H3O plus is equal to the quantity of OH minus, then your solution is neutral. And that is what is there in water. Okay. So H3O plus, OH minus, you have equal quantity of it. None of them are dominating, which is why water is neutral. If I add a strong acid to it, okay, so you can see that already there are H2O plus and OH minus, but because the strong acid is giving out even more H plus out of it, you have more quantity of H2O plus than OH minus, like more of H plus than OH minus. So something is acidic if the quantity of H3O plus is more than the quantity of OH minus. So then you call that the solution is acidic. Then instead of a strong acid, if I add a strong base, now the base naturally contains like a cation and OH minus ion. So if the quantity of OH minus is greater than the H3O plus ions, then the solution is basic. Okay. So simply containing H plus or OH minus is not like it's not how you get acidic or basic solutions. It is which is dominating in the solution itself. If both of them are equal, then it is neutral. If H plus is dominating, then it is acidic. If OH minus is dominating, then it is basic. Okay.
Just can you click on water once again?
Yeah, I will. So pure water. Yeah, two molecules, they break down. You have some H3O plus and you have some OH minus. So you can see that in the pH value also. So when you look at a strong acid, you can see that, for example, if the pH is 2, you can see that there is complete ionization. You have only the negative ions and all the H plus ions have attached themselves to water and you have this. Okay. And in the case of a base, you barely see any H plus ions, like OH minus ions are the ones dominating because the OH minus is being contributed by the base itself. Okay. So yeah, like when you talk about acidic and basic solutions, it is in the relative quantity of H3O plus and OH minus. When they are equal, then it is neutral. If the H3O plus is a lot more, then it's acidic. When H3O plus is less than OH minus, then it is basic. So this concept is important because this will also relate to the whole concept of your acidic salts and basic salts. Like, why is sodium carbonate? So yesterday somebody had mentioned example of base as sodium carbonate. So I mentioned sodium carbonate is not a base, but it is a basic salt. And the reason why is it comes from this whole concept. It relates to this concept. Okay. Now, let's look at the, what do you call? The difference between a strong acid and a weak acid and that whole thing.
Ma'am, can you please show that the written thing?
Yeah. Okay, I'll keep it this thing here. Okay. So if I have a solution of a strong acid, what ions do you observe in the solution? Make a note of it.
H plus.
The H3O plus orange colored, and what other ions?
A
Ma'am, do
minus
we need to make
acid.
note of this equation?
No, you don't need to. I mean, this we've already written, right? Like I have put it on the whiteboard. What happens when acids are added to water?
Done, ma'am.
No, but I want you guys to observe what is there in the solution. Okay. So when I added a strong acid, what all are there in the solution? Make note as in like just observe and tell me what you see here. Yeah, what do you see?
One is the H3O plus ions and the acidic ions.
Okay. So just these two, or is there anything else?
HCO plus ions there are many H3O plus ions.
And anions. Just these two, right? Like only these two, or is
And ions are very less
okay.
compared
No,
to
Aditya, technically they'll be equal amount, but yeah, because this is a bigger one, it looks like it's a lot. Okay. Now let's see what if there's a weak acid. Now what do you observe?
H ions are also there.
Comparatively lower number of H3 plus ions and anions.
Yeah.
Yeah, lower
And more
numbers.
of the
And H ions are added.
Yeah. And what is happening is, in the case of so when a strong acid was added, do you find any of the original HA molecules here?
no, they are gone.
Yeah, they're all, there's a complete ionization, right? You just see H2O plus and A minus. But in the case of a weak acid, along with the orange and blue ions, what else do you see here?
H3 plus ions.
So HA molecules, like all the molecules are not ionized. Only some of them have broken down into ions. The rest of them are still intact as HA itself. Yeah. So that is the difference between a strong acid and a weak acid. Okay. And what else do you observe as the difference between a strong acid and a weak acid? What about their pH values?
So for the weaker acid, pH is more towards 7, and for the strong acid, it is away from 7, like it is more stronger.
That's a nice way to visualize it. Yes. Or in other words, if something is more acidic, the pH is lesser. More acidic it is lesser. Right? Okay. So same as the case with a strong base and a weak base. So in a strong base, you don't find any MOH molecules. Like it is completely ionized into M plus and OH minus. Only yellow and blue is the only things you see here. But in the case of a weak base, you see the intact molecules also. Only some of them have ionized, not all of them have ionized into B plus and OH minus. Okay. So that is the major difference between what we classify as strong acids and weak acids versus, or what we classify as strong versus weak. So it is purely in how many ions they can produce. So if it is completely ionized, it is classified as a strong acid. If it is partially ionized, if you have like intact molecules also, then that is classified as a weak acids. Or weak acids, you don't get as many ions from it as you would get with a strong acid, that way. Yeah, so that's like a major concept. Now, pH is an interesting thing. So pH is what you use to measure the strength of a solution, whether it is acidic solution or basic solution. Okay. Measuring something with numbers is really important because it gives you an idea. If I just tell you, look, I have HCl and H2SO4, one is strong, the other is less strong. That's not the, you can't do anything with that information, right? Like it's all vague and up in the air. But if I tell you, okay, I have HCl and H2SO4, the solution of, the pH of solution A is 2 and the pH of solution B is like 5, you will have a better idea as to which is safer and which is more dangerous. So pH is literally a quantized way of measuring the strength of an acid or a base. pH is how you measure. So just like how you measure length in meters, like mass in kilograms, like you give it a number, right? So that you know that something is 100 grams, 150 grams, 200 grams. Similarly, pH is, just assigning a number to like how you measure the strength of acids and bases. Yeah. So mathematically, pH is basically equal to negative logarithm of the concentration of H plus ions. You won't be asked problems based on this because, yeah, you're not taught what logarithm is, but yeah, just, for your information, just like write it down and keep it somewhere so you'll have a better idea. So the range of pH. So what is the range of pH?
0 to 14.
0 to 14.
Yeah, goes from
0 being for the strongest acid and 14 for the strongest base, and 7 neutral.
Correct. So basic and 0 would be acidic, and right in the middle at 7 is what is considered as neutral. So neutral, as we've seen earlier, when H plus is perfectly equal to OH minus. Basic is basically when you have mostly OH minus, and acidic is when you have mostly H plus ions. So pH is a measurement of how many H plus ions you have, and like it's not a direct measurement, but it's basically you take the measurement of H plus ions and then you do all of this mathematics with it. So
how to calculate number of H plus ions?
So that it will, like, this stands for the concentration of H plus ions. So where are you getting H plus ions from? Puneet?
Yeah, ma'am.
Yeah. So you asked like where do you get this number from, right? So it's concentration of H plus ions. So where do you get H plus from? Like what is the source of?
From the acid.
From acid. So if it is something related to acid, it is pretty straightforward. You figure out how much of acid that you took in the solution. Did I take 10 ml in 1 liter of water? Did I take 100 ml of acid in 1 liter of water? So based on that, you can estimate how much H plus you have. If it is a basic solution, then the solution contains both H plus and OH minus. So neutral water ka, we know that like it is a constant, like there is a measurement of how much H plus, how much OH minus you have. Then based on what base you took, like how much of a base you took, uska, like there is a way to derive the quantity of H plus ions if you know how much OH minus ions are there. So it's a little complicated. Like this is exactly what you will study in grade 11. Like the whole chapter equilibrium is based on, figuring out the strength of acids and bases. So yeah. So yeah, where you get the value of this, simple answer is basically, you know how much of an acid or a base you took. So based on that number in ml, you can convert it into the concentration of H plus. So you convert that ml or grams into the number of moles, and that's how you proceed with that. Okay. But yeah, coming back to this, pH, the range is 0 to 14. The smaller is the pH number, the more acidic a solution is. Greater is the pH number, more basic the solution is. Okay. The kind of questions that you get based on the whole concept of pH is you'll be given a number of solutions like A, B, C, D, E have pH of 2, 5.5, 7, 9, 10. And then you'll be asked to arrange it in the order of, acidic nature or basic nature, that sort of a thing. Yeah, Devi, what's up?
Ma'am, anything to write in notes? This
You
from this.
can just like mention this. You can write down this part. What is pH? The formula for calculating pH, and what is the range of pH? What do the values mean? Acidic, neutral, and basic.
So the whole slide, no.
Yeah. Yes. Oh, is that indicating that you're done noting down? Okay.
Ma'am, actually I got logged out. So what we have to write or what are you doing?
Whatever you see on the board, just make a note about it.
Okay.
Ma'am, what have you written in red color?
Huh?
What have you written like pointing the arrow? Yeah.
Oh, this part. So this is says like something in square brackets, like this part means it stands for concentration of H plus ions. So this, if you want, you can note it down, otherwise you can let it be. This is, you're not going to use this formula as such. So if you want, you can write it down, otherwise. Okay, done? No, still noting down. Okay. So Tanisha, Snehal, Shakti, Ritvik. So Abhishek, Aditya, and Ritvik. Okay. So this is one way, like this is like the kind of more accurate way of measuring pH, because you're giving a proper number to it. Another way of, like if you just want to know, like if you have a solution lying around, if you want to know whether it is acidic or basic or neutral, or what is the status of it, you can use different indicators. Just like the word indicator is coming from something that indicates. Okay. So common indicators, you have litmus, then you have universal indicator. This is what is used in like your commercial pH paper that you get in the market, like this. Then you have something called phenolphthalein. Then you have methylene blue. Sorry, methylene orange. Methylene blue is a different thing. What other indicators? So these are all visual indicators.
China rose.
Ma'am, you also
Yeah, Shakti, you were mentioning?
China rose.
China rose is one. That is another one that changes colors. Yeah. So these are all visual indicators. Visual indicator meaning visual. Matlab, they indicate things with sight. Like they basically change color depending on whether something is acidic or basic. Okay. So litmus, you all are aware of. So how does litmus change color when it is an acid versus when it's a base?
Ma'am, when
Blue
blue
turns
litmus
red
paper
when
turns
acid and
red in an acidic solution,
Yeah.
and red remains red, whereas in base, red changes to blue and blue remains blue.
Correct. That's pretty accurate. So basically, litmus, when it's in an acidic solution, matlab, if the solution is rich in H plus ions, then the chemical composition of litmus changes such that it becomes red in color. So that's why if you put a red litmus in an acidic solution, it remains red because that's its natural state. And if you put a blue litmus in an acidic solution, it becomes blue, turns into red. Similarly, base matlab, if it's in a solution dominated by OH minus, then yeah, litmus has a tendency to become blue because that's how the chemical composition is changing. Okay. What about universal indicator?
Ma'am, universal indicators include turmeric or something, or what? I don't
Yeah,
know.
so universal indicator,
this numerical indicator is what actually like the
correct. So universal indicator is more accurate than litmus because it is not just a binary thing like, either this or that. So it has different scales of it, depending on how strong the acid or the base is, you get different colors out of it. Yeah. So the universal indicator turns into many different colors depending on what solution it is being put in. Are you guys able to see this clear?
yeah.
Yeah, there you go. So all the red, orange, yellow side of it is acidic. Then the cooler colors like greens and blues going up to dark magenta is the basic side of it. Okay. So it goes through red.
Ma'am,
Yeah.
ma'am, so while experiments, we always use a universal indicator or the pH scale.
So it depends. Like if you just want to check finally whether something is acidic or basic, you use a universal indicator. And if you want to know an approximate value, yes, like commercially, you can see that along with the color, you can compare the color and you can figure out what the approximate pH value is. Like you're given numbers here. Agar pH 3 hai, so this is the color you can expect. Kind of like that. Agar pH 5 hai, so this is the color you can expect. Okay. So again, it completely depends on the purpose. It's not like a single set rule that laboratory mein yahi use kare. A lot of titration reactions. So like suppose you have an acid, but you want to calculate ki uska concentration kitna hai. For that purpose, phenolphthalein is used. So phenolphthalein, okay, off the top of my head, I forget, but it basically changes pink and colorless. So if it's an acidic solution, then it becomes pink, I think, and if it is basic, then it becomes colorless. So this is the binary thing. Methylene orange also, methylene orange and China rose, I haven't seen it used so much, so I don't remember the exact.
Ma'am, for China rose, the acid turns bright red.
Oh, thank you. That's good. And
then for the base, it turns green.
Green. Okay. There you have it. This is the indicator. Methylene orange, yeah, you guys can do a quick Google search and you'll get the reference. Mostly in laboratories or experiments and all, these are the 3 solutions that are used. And the way they work, why they change color is, again, these are all specialized chemicals. And when you have excess H plus ion, they undergo one type of reaction, and the result of that reaction is this particular color change.
Ma'am?
Right? Yeah.
Ma'am, for methylene orange, it turns red in an acid and yellow in bases.
Oh, thank you, Shakti. So this one's range is red and yellow. So neutral is basically orange. Yeah, that's why it's called methylene orange. Yeah.
Ma'am, for phenolphthalein, its acidic is pink and base is colorless. Right?
Ah, that was right.
But ma'am, in the book it's colorless and pink. So
Yeah,
base is acid.
Okay, this I wasn't sure. That's why I mentioned. I know it turns pink colorless. I just couldn't remember which is for what. एक acidic में होता है, एक base में होता है. But pink purple if it is basic. So it's the other way around. I can just correct it. So it's colorless in acid. And so it's like a really dark pink color, like almost purplish.
So ma'am, what's the original color of phenolphthalein if it has any?
Phenolphthalein original color,
it is colorless only, no?
Colorless, yeah.
So ma'am, we can say it has no change when acid comes in contact.
You could say that, but if you're originally, so like the way phenolphthalein is used is, suppose you have an acid of unknown quantity, like you don't know how strong an acid is. Then you take a base mixed in with phenolphthalein, and then you neutralize the solution by adding the acid until the solution turns colorless. So then you know that, okay, it's not basic anymore. All the base has been neutralized. And then you can see how much acid you have used and you can estimate the strength. And again, if you're trying to figure out the strength of the base, then you take a colorless solution, you do the same thing until it changes the color, and then you figure it out like that. So it's not used in the same way litmus or the universal indicator is. Phenolphthalein is mainly used in titration. So depending on the situation, either you take a colorless solution or a pink purple solution and do it until the color changes. Yeah, Aditya, what's up?
Yeah, ma'am. I just wanted to ask that since phenolphthalein is colorless, then how can we recognize when some diluted colorless solutions are there on table? How can we recognize if it's the phenolphthalein?
That's why all the jars in a laboratory are labeled. That's why it's like, it's not good manners to leave random solutions out. And then I'm telling you, right, I just mentioned, so phenolphthalein is used in a very specific purpose, you know, when you're trying to estimate the strength of an acid or a base, and then how you estimate the concentration, like strength in the sense concentration, is you do a neutralization reaction and then you figured out, acha, I've taken 100 ml of the base और उसके लिए इतना acid लगा, तो what would be the concentration of the acid for that? It's like a whole process. What are you guys doing for practicals? Like, do you guys have any practicals this year?
No, but
Ma'am, till now in school, they are making us do it on O labs. Chemistry, bio, and physics.
They're making you do them in online labs.
Yeah.
Yeah, they show us videos and all.
Oh, okay.
yeah, and
There
our
are some
test is also there,
stimulations
practical
on
test.
So
some
you
stimulations are also there on O labs, so we do it.
For ours, we had to do it on our own. Like I had litmus, and my classmates had China rose extract, then purple cabbage. I'm sorry. Then turmeric also people had. So
okay.
we used this.
So you okay, it's with the household things only they're making you do. Okay.
That's what.
So instead of taking the real practicals, are asking us questions in exams for that.
Sure. Okay.
Ma'am, but if this continues, so this year in 10th also we will not have any practicals.
Yeah. Really looks like it. Unless, you know, by the end of the year, things get better and just in case, you know, they let you back on campus in Jan, Feb or something like that. Doesn't look like it.
Our practical exams are there next month only.
What? Oh, so I mean, that also they're going to
They
ask you.
told us not to perform anything but to write the whole experiment.
Wow. So you have to like memorize the experiment without knowing what's going on.
Yeah, they showed us like full simulations and then we have to perform.
Ma'am, in
Carry
our
through some-
Billabong, they have said that we have to, they will give us some particular time, like 5 to 10 minutes, and we have to do this simulation and upload these screenshots of it on Shobi.
Anyway, speaking of visual indicators, you know, just to give you guys an idea, like I have pH paper here. I have made some solutions here. So here I've got some lemon juice. I'm going to take a tissue so that I don't. Okay. You guys able to see?
No, ma'am.
Now?
Yes, ma'am.
Yes, ma'am.
Okay, in a flat transparent thing, I just took some lemon juice. So let's see what the color change is gonna look like. Okay, do you guys see the color
Ma'am,
change?
it turned, yeah.
So let's see how strong this lemon is. I added a couple of drops of water, so it's not just lemon juice. So if I were to estimate iska pH, how much do you think iska pH would be?
Ma'am, 5.
5.
5.
Yeah.
5.5 actually. Yeah.
Slightly on the weaker side. It's not as
Approx 5.
as
Yeah.
Okay. Yeah. Between around 5 and 6. Okay. Then I've got, let me take another strip. You can see the natural color has changed. It's supposed to be greenish, neutral, but it's taken on a yellowish tinge. Can anyone figure out why?
Ma'am, because of
Oxidized?
some reactions.
Sunlight. No, I keep it like inside only, but
Moisture?
moisture, good guess, but moisture is water and water is supposed to be neutral, right?
Ma'am,
But it contains
I
impurities
have
also,
the
right?
Huh?
It contains impurities also, na water.
Yes. What sort of impurities? What is making it like yellowish? Matlab, it's more on the acidic side. So what's making it acidic? Shakti, you were saying?
yes, ma'am. I have the same pH paper, but and like it's got staples on it. The book itself, it's got staples on it, and it's turned green around the staple.
Ah, there you go. So staples, hai na? So that's more of a staple alloy. Yeah. Okay, I've got another solution. You can't see it because it's basically
Ma'am,
transparent.
the air, ma'am, can it be sulfur dioxide that's in the air reacts with the water that makes H2SO4?
Wow, good theory, Raghav. Definitely one of the factors, but
Yeah.
that is not the major this thing. It's not the sulfuric acid. It's not that major.
Ma'am, which solution it is? The transparent one.
You guys tell me. Acidic or basic?
Water.
Neutral
Yeah, it is not changing.
water.
It is water.
Water is
Yeah.
green hona chahiye, but not a lot of change, right? So basically, I mix some hand soap in it. So
Then it would be a bit basic, weak basic.
It should be basic, but again, it's like Dettol, and I don't know what are the other substances that are there, right? So it's not like purely basic. It's still not as acidic as lemon juice, but still like slightly on the acidic side, right?
Ma'am,
This
if
Ma'am,
you
if you
use
see
cloth,
color papers are
soap, it'll
different.
turn
You can
green.
use baking soda.
Baking soda, yeah, that's what I planned to use, and then I realized I don't have any more baking soda in my kitchen. I need to get some.
Eno is
Use
also
cloth
there.
soap.
Also, I need to like raid my kitchen and see what we have. But yes,
Ma'am,
check.
ma'am, can you show the script that came in contact with lemon juice actually?
Yeah, this one is the one that came in. This again.
Miss, why there's so difference in color, like normal color between both these strips? One is like very pale yellow and the other is peach.
Ma'am, but
The difference in color?
Yeah, like one before you dip, there was a difference in color in both the strip, right? Why
Yeah.
so?
Because one I dipped it in lemon juice, so because of the acidic nature, this turned like really red. The part that
No,
was
before you dip.
before I did. Oh, shit.
Okay, got it.
Ma'am, the soap one is turning into pink.
Yeah, because
Gradually.
I'm basically touching all three of them, right? So some acidic thing has leaked on. Let me take a new fresh strip. Okay, so one in soap, one in lemon juice. So now you can
Miss,
see.
where do we get this paper? Amazon?
Amazon, definitely. This I bought it a couple of years back, pre-pandemic, in a stationery store. So stationery store, if your local stationery store doesn't have it, you can order it on Amazon. And I will ask you guys to try it with different things. You can try it with a dish wash soap, dish cleaner, with coffee, with tea, the things around you.
Ma'am,
Yeah.
Ma'am, you can use cloth soap, Surf Excel.
Yeah, absolutely. Detergents. Yeah.
ma'am, are we having a Saturday class, physical class, Saturday, Sunday physical class?
Yeah, so you will have it on Sunday, 2 o'clock to 4 o'clock. And yeah, that is confirmed. And I wanted to do chemistry with you guys. It will be a mix of acid, bases, and salts, and also chemical reactions and equations. Wherever you're having trouble in balancing or like figuring out the equations, reactions, we can revise.
Ma'am, for Podar
So
also?
Sunday
Or
class will
is
be
it
a full chemistry, right?
Yeah. Podar, I'll let you guys know, because one, we'll need to check the space, and second, it's in Malad, right? It would be kind of far for a lot of you. guys, in case you're staying.
Oh, it's physical. Oh, sorry. I thought it's online.
No, physical. Okay, so this
Ma'am,
is,
are we starting physical class?
sorry, Shakti?
Like for the rest? So are we starting physical class for like everything?
No, it's not a complete shift. We're just testing waters out. It comes with a lot of restrictions because on weekends we're not allowed to be open. So just testing the waters out, seeing how it goes. If it is safe.
Okay, ma'am.
Yeah.
Ma'am, anything to bring specific?
Bring your notebook, pens definitely, different colored pens, like the way you would for making notes here. Mainly these two. Yeah, bring your notebooks and pens. So apart from this, is there anything that you guys are not confident with? Like, because physical class may the clarity is a lot more, when it comes to teaching, practicing and all of that. So any math concept, anything you want to discuss, we can do this. Vasudha, you're logged out. How long has it been? We had done a whole experiment with pH papers and all. What have you missed? 5 minutes. Okay.
Miss in maths and the trigonometry part, like just one part where we have to prove. So it is a difficult like to get know from where do we have to start.
Okay. But yeah, we can discuss. Okay. So yeah, after class, I'll make a proper formal announcement on the WhatsApp group, and then you guys can put in your suggestions there. Yeah. Okay. Now continuing with the pH thing. Right. So pH scale, measure of acidity, alkalinity, goes from 1 to 14. 7 is the middle neutral. Okay. Important points, it gives the measure of acidity or basicity. It's literally a physical measurement. Ranges from 1 to 14. It should be thought of simply as a number which indicates the acidic or basic solution. मतलब उसका कोई units नहीं है. It's literally just one single number. So it measures the hydronium ion concentration. So that's what I put the formula, right? So higher is the hydronium ion concentration, lower is the pH value. इसलिए basic solutions have really high pH and acidic solutions have really low pH. This is the formula, and these are the colors. Okay. Strengths of acids and nature. So pH measures the strength of acids and bases. Strength of acids and bases, when you're measuring it in terms of pH, right? It doesn't depend on what acid or a base that you took. So for example, if I took a solution, like if I took CH3COOH, jiska pH is 3, like I took a really concentrated thing. And if I took HCl, jiska pH solution mila hai 5. Okay, let me call this A and let me call this B. So which solution is more acidic, A or B?
A.
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 And the lower the number on pH scale, it's more acidic.
Very nice. All of you agree. Is there anyone who is saying B? Like 7 of you have given an answer, but there are like 20 plus. So everyone agrees it's A, or is there anyone saying it's B? Okay. Whoever answered yes, I'm glad you guys answered A, because absolutely A is more acidic. Ryan, absolutely. This is more acidic because even though HCl is a stronger acid, you didn't take enough of it. Like you diluted it so much that pH value is, like it is, you basically made it less acidic. Okay, so that's one thing that you need to consider. But if you took an equal quantity of acetic acid and hydrochloric acid, then yes, hydrochloric acid is definitely more acidic.
Ma'am, the
Yeah.
full form of pH is a power of hydrogen or something else?
Yes, power of hydrogen. P stands for power, and H is literally the hydrogen ion concentration. So remember the formula pH is minus log the concentration of H plus. So similarly, there's something called POH, which is minus log OH minus. Like all of this exist. So you'll come across all this in case you take chemistry in grade level. Yeah. So strength depends on the amount of H plus and OH minus. The way you can manipulate the quantity is either by taking a strong acid which can release H plus easily, or you can take lots of a weak acid so that even though the ionization is not a lot, you can still make up for it with the quantity. So pH purely gives you how, like pH is the true measure of how strong an acid or a base solution is. Okay. In general, yes, organic acids are weaker than your mineral acid, and that relates to how easily like your mineral acids are ionic. Like sulfuric acid, hydrochloric acid, they can ionize easily, but organic acids, because they are carbon based substances, they are covalent compounds, so ionization is not as easy as the other thing. Yeah. Oh, there you go. You have the different indicators with their indications. Importance of pH, or rather like acids and bases in everyday life. Yeah, the reason why we study about it is like it's quite important for the world to run, the world to function. So plants and animals, living organisms require a specific pH to survive and function. Can you guys give me an example of this particular specificity, like this specificness that you guys have studied in life processes?
Ma'am, our body contains HCl that's very diluted. That's only to, it's not to do anything but give a acidic
Stomach.
acidic environment for the toxin to work.
Correct. Raghav, you are right, except for one part. The HCl
It is
that's in your
concentrated.
stomach is concentrated. It is not at all dilute. So your stomach functions like that particular reaction where you need to break down that protein. That can happen only at a pH of 2 or something. It's like highly, highly acidic. Which is why, your stomach is an amazing, amazing thing. Because of your stomach acid, even if you do the 5-second rule and all of that, right? Like a little bit of impurities, your stomach acid kills the microbes and all of that. Like living things can hardly survive in there. So that way it's okay. Neki is asking, what about urine? Urine is mainly around neutral, but it will keep changing depending on how your body is. Like for example, if your liver doesn't work properly, right, then the bile is secreted, and that's why when someone gets jaundice, then their skin becomes yellowish and your eyes have like a yellowish tinge. So if that bile happens to get into your urine, then pH is going to be really high. If you're like everything is normal, everything is like healthy, then it will be close to neutral. So yeah, it completely depends on your body's functioning. That's the reason you do urine test, to figure out, okay, what all substances are there in urine. That's how people figure out if you're healthy or generally blood ka pH is 7 point something. That's close to neutral. Oh, there you go. Body functions at a rate of 7 to 7.8. pH of soil needs to be specific range. Now, again, this depends, it changes from plant to plant. Some plants require like really alkaline, high pH soil. Some plants are okay with low pH soil. Some plants require it to be neutral. But every plant, it needs to be in a specific range. It changes from plant to plant, but that particular thing needs to be there. pH of rainwater is less than 5.6. Acid rain, you guys have studied like non-metal oxides, when carbon dioxide, sulfur dioxide.
Sulfur dioxide and nitrogen dioxide mixed with
Yeah.
it.
So all of these gases, they dissolve with water, they form acids, and when that falls down, it's called acid rain. That's the reason your parents, like start of rainy season, people say, okay, do not get wet in the first 2-3 rains of the season, because that is impure, that's acid rain. When
corrode the buildings also.
yeah, that is like in really insane, like really high concentrations, then yes, that corrodes buildings. Again, it depends, like if your building statues are made out of marble, calcium carbonate, you've studied that acids react with calcium carbonate, so that kind of thing that happens. Okay. Second point itself, a digestive system we were just discussing. So stomach produces HCl, helps in digestion of food without harming the stomach. Okay, it's not like there's a completely different.
Stomach releases mucus.
Yes, there is a mucus lining for that. During indigestion, so when you eat a lot, or even if you stay hungry for a long time, if you don't eat, or if you eat too much, then you have, like, the word acidity comes from the fact that there's too much acid in your stomach, and that causes pain and irritation. Sometimes you get acid reflux also, like if a tiny bit of that acid gets into your esophagus, you get those like a weird burp and heartburn and stuff like that. So the cure for this is antacids. So what do you think is the nature of antacids?
They're basic in nature, so
Basic in
that
nature,
they
like
can
toothpaste.
neutralize the reaction.
Absolutely, yes. So antacids are basic.
It's mostly magnesium hydroxide, right?
Magnesium hydroxide used to be used in the olden days. Now, of course, the formulas have become a little more sophisticated. Bicarbonate is also used. Yeah. So magnesium hydroxide is called milk of magnesia. So if anyone's like keen on history, if you keep researching historical texts on the internet or whatever, if you come across something called milk of magnesia as a cure for stomach upset, it's nothing but magnesium
Yes,
hydroxide,
ma'am.
and it'll help with, it's an antacid. Okay. Tooth decay. All right, so this is a whole process. Okay, you need to brush your teeth. Have you ever checked the ingredients list on your toothpaste?
It is basic in nature.
And why is it basic in nature?
We studied this in life processes also.
Oh, you had this in life processes. Okay, but why is
the bacteria acts on sugars to produce acids.
Yes.
Like the effect of the bacteria.
Decay.
Correct. So what happens is, mouth is full of bacteria, like your skin, mouth, everywhere is full of bacteria, but specifically your mouth. And when you eat things, more than 50% of what you eat it'll come under sugar. It doesn't have to be pure sugar, but even carbohydrates are considered as sugars. So bread, roti, rice, potato, like even your maida, snacks, all of that is sugars, right? Now the bacteria living in your mouth, they are also living things, they also need to eat. So when they act on the sugars, basically they are eating the sugars, they release acid. It's basically bacteria poop, which is acidic in nature. Now, what do you know about teeth and bones? Like, what are they made up of?
Calcium.
Calcium compounds, like calcium salts and phosphates, basically, right? And again, calcium compounds are basic in nature, they're sensitive to acids, which is why when the bacteria is secreting or releasing the acid after acting on sugars or the food particles, they start decaying your teeth. So that's how tooth decay happens. And that is the reason after you eat or before going to bed, like end of the day, you brush your teeth with basic substances so that you neutralize that acid before it can act on your teeth. Okay, so that is the funda of tooth decay. Self-defense by animals and plants through chemical warfare. So this sounds badass, but at the molecular level, it actually is. So whenever an insect stings you, bites you, like whenever you feel pain, you feel that pain because there is an acid literally corroding your skin. Okay. So most of the acid, they're organic acids like methanoic acid,
Acetic acid.
acetic acid less so, that's more vinegar. Ant stings contain methanoic acid. Bee stings contain like a mixture of acids.
Ascorbic acid?
Ascorbic acid is, that's vitamin C. That's like a component of
grapes.
Yeah. So these are like a different set of acids, like specific to these things. Yeah. So that causes pain and irritation. Even plants. So there's something called stinging nettles. Are you guys aware of it? Like, have you come across this like in any shows, YouTube videos, anywhere?
Yes, ma'am.
Oh, you have. So stinging nettles are
This
stinging.
is a park one.
Yeah, it's kind of grass. It's like weedy, and they sting because they release acid. And yeah, how many of you have eaten pineapples? Not on pizza, like just raw pineapple. How would you describe the experience? Aditya or Neki also?
Sour. Too sour.
Sour, right? Okay. Have you ever had a pineapple without like putting salt over it or putting salt water over it?
Yeah.
Yes, ma'am.
What did that feel like?
Yes, ma'am.
Fresh pineapple, not the canned ones.
It tastes
Much
nice,
more
except
sour.
that like your tongue starts getting
What happens when
prickly,
you
something like that.
Yeah.
It
So
starts prickling you.
that's prickly, right? So that is again because of acid. So it's like the pineapple is literally attacking you because you ate it. So the acids in the pineapple are, yeah, acting on your tongue. That's why you feel it really prickly and weird. Yeah. Yeah. So that. So some of the natural acids are given here. Ant sting, yeah, I mentioned methanoic acid. Nettle sting is also methanoic acid. Okay, interesting. So methanoic acid is also.
Hello, excuse me.
Yes.
Hello.
Yes. Good afternoon. Hello. Okay. All right. So methanoic acid is also called formic acid. So you can make a note of this.
Hello, ma'am.
Yes. Yes, Ms. Prajapati. Tell me.
हाँ मैम, मैं नील की मॉम बोल रही हूँ। आपसे कंफर्मेशन करना था, नील क्लास में था कि नहीं, मतलब उसका ज्वाइन दिखा रहा था कि नहीं।
Like पहले like first मैम आपको क्लास के बाद मैसेज करती हूँ in some 5-10 minutes.
ओके, अभी ये ज्वाइनिंग है क्लास में? कुछ समय पहले, 5 to 10 minutes पहले, वो कंफर्म करना था मुझे।
हाँ, 5 to 10 minutes पहले he was there. Yes. I saw the name.
ओके। कुछ प्रॉब्लम है तो प्लीज आप मुझे मैसेज करो। ओके।
Yes, definitely.
ओके।
Okay. Coming back to this, yes, methanoic acid is also called formic acid. So you can make a note of this. In case you come across any question talking about it, don't be clueless, like it's nothing but this. So vinegar, acetic acid, we've discussed. Curd, lactic acid, we've discussed. Lemon is citric acid, orange is citric acid. Tamarind and tomato, these are like new ones. Tamarind is tartaric acid and tomato is oxalic acid. Okay. Yeah, so that is it about acids and bases. So the main points is knowing about the strength of acids and bases, like what actually is happening in water and what contributes to the strength and how the reactions work. And the other major thing is the indicators part of it. How do you measure the strength of acids and bases and the practical applications of why acids and bases are important? Like where do you find them in nature? How do you work with them? Yeah. So we have the salts part remaining. So tomorrow we will be discussing